During the last ice age, 16,000 years ago, ice sheets like this covered much of the northern hemisphere. So much water was trapped in the ice that sea levels were almost 122 meters, 360 feet, lower than they are today. Today, we're facing the opposite problem. The Greenland Ice Sheet, the last remnant of that ice age, is melting at a rapid pace as the Arctic heats up. Greenland's ice sheet lost 55 billion tons of water over just 5 days in July and August of 2019. Enough to cover the state of Florida in almost 5 inches of water. Scientists are packing equipment and getting dropped off at research camps across the ice caps to track the melt. "30 years ago, this research site, S10 Camp, was chosen because it was just above the equilibrium line. That's where the snowfall and the snow melt are the same, year in and year out, making the ice very stable. From here, scientists can measure the long-term climate and monitor the movement of the Greenland ice sheet.
It was originally put in as a kind of control where nothing happens. Nothing really should be happening.
Nothing should be happening here, but the ice sheet is melting, and faster than models predicted for this century. Airborne dust and soot from the industrial world darken patches of ice, absorbing more of the sun's radiation and accelerating melting.
It's an amazing theory out there that the water gets to the base of the ice sheet and kind of pressurizes and hydraulically lifts the ice sheet up to a meter at any one time when that water shunts down the hole. So it does have a really big impact. And the rate of lowering of this particular part of the ice sheet is beyond what models predict, really.
By the end of summer, scientists estimate about 400 billion metric tons of ice will have melted or calved off Greenland's giant ice sheet. Scientists worldwide are studying sea rise and the ice loss on this vast ice cap. Greenland is 14 times the size of England. Most of it is covered by an ice sheet. Its average is 2 kilometers thick.
But in just the last 10 years, there's been a lot of change.
And in the center, almost 4 kilometers deep.
6, 5, 4, 3, 2, 1, drop. 6 feet away.
A Jet Propulsion Lab program called Ocean Melting Greenland is designed to improve sea level rise estimates by mapping topography of the sea floor and measuring salinity and temperature along the continental shelf of Greenland.
It's really a breathtaking landscape. When you look out the window, you really get a sense of just how huge these glaciers are, these gigantic rivers of ice that are draining the ice out of Greenland into the ocean.
JPL's team lead, Josh Willis, drops high-tech probes designed to measure the action of warm, salty Atlantic water, then resurface and transmit data to the plane, all to determine how the ocean is contributing to the melting ice walls.
These are actually the data bits coming through on the radio.
Greenland's definitely melting, and this year has been incredibly warm. As we've flown over the ice sheet this year, we've seen evidence of melt pools, not just in the coast, but far inland, even at very high elevation. So it's been a really warm year, and I think it could be a record year of ice loss for Greenland.
Here's our scientific gear. We have a time-lapse camera so that we can actually see, when it's calving icebergs. The real frontier today is understanding the ocean-glacier interactions. And even though Greenland's a faraway place, the changes here are felt around the world. In 2005, we put cameras at the 𝗥𝗲𝗹𝘁𝗲𝗀 Glacier, and now we have cameras at more than 10 glaciers. Every time you learn something new, the actual speed measurements, the 𝗥𝗲𝗹𝘁𝗲𝗀 Glacier is moving really fast. It's discharging 40 billion tons per year.
40 billion tons of ice. That's equivalent to over 90 million 747s fully loaded. With fuel.
That whole kind of ice shelf is going to go.
The time-lapse camera is set to take a single picture every 30 minutes. It shows the movement of the glacier over the entire summer. The front of the glacier is rapidly disappearing. One reason is the heavy flow of fresh meltwater down to the sea. Another is warmer ocean currents reaching the face of the glacier.
My concern is that if ocean temperatures continue to rise and there's more of these warm currents in contact with all of these outlet glaciers to the ice sheet, we're just going to see more and more ice coming out at a faster rate, leading to global sea level rise.
Where these glaciers extend out into the ocean, warmer ocean temperatures are melting them up to 100 times faster under the surface than above. Temperature rise and melting in the interior causes the ice sheet to lose more ice than it gains each year. In turn, the equilibrium line is retreating further inland, while the glaciers are sliding further toward the coast and into the warming oceans. The question is, how fast?
The ice sheet's spending more than it's gaining. That's why it's important. We want this ice sheet to be in equilibrium. Sadly, it's not.
GPS sensors can precisely track the melt and the movement of the ice sheet.
GPS, it's telling us how fast the ice is moving here, pretty much on the button of 51 meters a year.
51 meters a year. That's how fast the glaciers are moving and sliding into the oceans.
Okay. Are we turning it all? I'm going to go left, if I have room. 3, 2, 1, drop.
Every time a ton of ice comes off of Greenland, sea level goes up a tiny little bit, and it's coming off Greenland at billions of tons per year.
If this lot were to melt and flow straight into the ocean, I suspect the rest of humanity would know about it pretty quick.
When we see surface melting over the whole ice sheet, I think that's going to really indicate something. That's going to tell a message. It's like the climate is really changing. This ice is nature's thermometer, and it just reacts to the environment that it's in. I think that's going to be kind of a wake-up call for people to see that, wow, for the first time we're melting in what used to be called the dry snow zone.
Eventually, if it all melts, the oceans will rise another 7 meters. That's 24 feet around the world, threatening coastal cities. It would be disastrous for many cities around the world, from New York to London, Shanghai to Sydney. Sea level rise will affect all of us. Worse, it's already destabilizing weather patterns in all parts of the world, coasts and inland.
So Arctic warming doesn't mean that the whole world just gets warmer. It actually means, because of the slowdown of the jet stream, that we have more extremes in the weather, and it's destabilizing climate.
In Greenland, surface melt, the warmer ocean waters washing in front of the glaciers, and shrinking sea ice are all happening at a fantastic rate. Satellite data shows that some of the glaciers have retreated as much as 10 miles per year in the last decade, and doubled their rate of melt. A further 2 to 3 degree rise in global temperature this century might be just enough to tip the Great Ice Sheet into an irreversible meltdown.